Hey guys, today we are going to talk about the properties of logarithms. So we will be able to expand and condense logarithmic expressions using the properties that we are going to learn today. So we're first going to talk about the properties of exponents that we already know. These properties of exponents are going to be related to our new properties of logs that we are learning today. So, if we have a to the n power times a to the n power, our property of exponent tells us that we add our exponents, so that we would have a to the n plus n power. When we are dividing a to the n power divided by a to the n power, we subtract our exponents and we have a to the n minus n power. Then when we had an exponent raised to another exponent, we multiply our two exponents to say that we would have a to the n times n power. We're going to take these three properties of exponents and relate it to our three properties of logarithms. So, this is a little bit blurry. So, when we have log base a of x times y, if we remember, when we had multiplication in our exponents, we then added them. So now when we have multiplication in our log, when we separate our log, we can then write it as log base a of x plus log base a of y. Then we have log base a of x divided by y. And if we think about exponents, when we were dividing, we subtracted our exponents. So now, with logarithms, when we're dividing, we're going to subtract our logs. So we have log base a of x minus log base a of y. And finally, we have log base a of x to the y power. And when we had a power to a power, we multiplied, and that's what we are going to do here with logs. Technically, this log base a of x is equal to an exponent, because in our exponential form, bacon and eggs or bay, we are equal to e, which is our exponent. So if we have a power or an exponent raised to another exponent y, we multiply that. So when we're talking about logarithms to make our lives easier, what we do is take this exponent y and bring it to the front so we can multiply y times log base a of x. So we're going to use these properties to then expand and condense our expression. So if we have more than one logarithmic expression, we are going to condense it to one logarithm. There are key things that we need to look for. We need to look at what operation we're doing with our two logs. Since we are adding them, it's telling me that we're going to multiply a and b, as well as if we are in the correct form. If you look back at our properties, we don't have any coefficients in front of our log, except for in our third property. In our third property, we moved our exponent to make it a coefficient of our log. So now we're going to do the opposite so that we can get in form of 1 or 2. So I'm going to take this 2 as my coefficient and make it my exponent of a. I'm going to take my 12 and make it my exponent of b. So I have log base 2 of a squared plus log base 2 of b to the 12th. I then use my addition of logs property, and I'm going to condense to log base 2 of a squared times b to the 12th. This is my condensed expression. Try this one on your own. We rewrite the dividing by 3 as 1/3 to get 4 log base 5 of a minus 1/3 log base 5 of b. Then we take our coefficients, move them to our exponents. Since we are subtracting, we are going to divide a to the 4th and b to the 1/3. And my final answer is written as log base 5 of a to the 4th divided by the cube root of b. I am taking my fractional exponent and writing it in terms of a root. Then we have the opposite when we need to expand our logarithm. So we're still going to look for our clues of what operation we're using. Here we have multiplication, which tells me I'm going to expand using my addition property. So I have log base 5 of c squared plus log base 5 of the square root of a. I can't have exponents in my log, so I'm going to move those to the front. And I have 2 log base 5 of c plus this square root of a can also be written as a to the 1/2. So I'm going to, in the front of log, put plus 1/2 log base 5 of a. My initial logarithmic expression is now fully expanded. Try this one on your own. I first distributed my power to both my numerator and my denominator of my log. So I got log of x to the 3rd over y to the 18th. This division told me that I would be subtracting when I split up my log into 2 logs. So I have log base 10 of x to the 3rd minus log base 10 y to the 18th. And since I had exponents in my logs, I moved them to the front, and I rewrote my answer as 3 log of x minus 18 log of y.